Assalamualaikum warahmatullahi wabarakatuh. My name is AKIF bin Muhammad IZANI, and my group will be talking about the topic input-output. First of all, I will be talking about the input-output module, or I/O module for short. What is a I/O module? It is a device that helps make exchange data and signals possible between the CPU and the external devices. Here is a diagram of how an I/O module generally looks like. At the bottom here is the links to the external devices, which is usually connected to the I/O module with a port, using a port. At the top here is the system bus, which consists of the different lines which will transmit the data to all the major components of the computer. At the right here is a picture of a real-life I/O module. As you can see at the top, this is a port which is the link to the external device, and the I/O module itself, which is connected to the computer. Now I'll be talking about external devices. So external devices basically just provide a way of exchanging data between the external environment and the computer. There are three categories of external devices. The first one being human readable. This one is used for communicating with the computer with the user. The two most famous human readable external devices is the keyboard and the mouse, which is found in every computer. The second category of external devices is machine readable. This one is suitable for communicating with other equipment such as the sensors or actuators. The last category of external devices is a communication. This one is suitable for communicating with the remote devices such as another computer. That's all from me. Thank you.
Assalamualaikum. My name is AHMAD Khairil AMIN bin HISHAMUDDin, metric number 2212947. Today I will talk about some examples of external interface standards. Let's start with SATA and PCIe. SATA is a technology primarily used for connecting storage devices such as HDDs and SSDs to a computer. SATA utilizes a serial connection, meaning data is transferred sequentially over a single wire. It provides a reliable and efficient means of transferring data between the computer and storage devices. On the other hand, PCIe is a high-speed serial bus interface used for connecting various components such as storage device and graphics card to a computer's motherboard. It utilizes a point-to-point connection where devices are connected directly to the motherboard, providing dedicated and high bandwidth communication between components. On a computer motherboard, a PCIe X16 version 4.0 slot has a bandwidth of almost 53 times as much as the SATA 3 slot. Next is the USB interface. USB, or Universal Serial Bus, is a widely used interface for connecting devices to computers. USB has evolved through different iterations, starting with USB 1.0 with 12 megabits per second bandwidth, until the latest technology USB 4.0 with 40 gigabits per second bandwidth. With each iteration, USB offers faster data transfer speeds, improved power delivery, and enhanced features. Next, Ethernet and Wi-Fi. Ethernet is a wired technology that utilizes cables to establish a physical connection between devices. It typically involves connecting devices such as computers, routers, and switches using Ethernet cables. Ethernet provides reliable and stable network connectivity with high data transfer rates. It is commonly used for local area networks or LANs in homes, offices, and data centers. Wi-Fi. The first Wi-Fi standard, 802.11b, introduced in the late 1990s, provided wireless connectivity at data transfer rates of up to 2 megabits per second. Subsequent iterations of the standard improved speed, range, and compatibility. The latest Wi-Fi standard, Wi-Fi 6, was introduced in 2019. It provides improved data transfer rates, supporting speeds of up to several gigabits per second.
Hello everyone, my name is ZEALOT Muhammad QURROTA. My metric number is 2118557. Okay, I want to explain to you about DMA. First, what is a DMA? DMA is direct memory access. It's a system that performs tasks to provide direct access to data without the need to go through a process on the CPU. With DMA, you can speed up memory operation and reduce the workload of the CPU. However, not at all input and output data can run this DMA system. Only certain or specific input and output data can be processed through by DNA. Okay, this is an example how DNA works. We can see in this picture, the red line is a normal memory process without using DMA. In this process, the I/O device transfer data to the CPU. After that, CPU transfer data to the memory. This process required is 2 cycles. It's not efficient, and while the blue one is the process of data transferring using DNA. In the processing using DNA, IO device transferring data directly into the memory. It makes the data transfer process only require one cycle to transfer the data. With DMA, we can shorten data processing time and reduce the work of the CPU. The way DMA works in a simple way is to reduce the work cycle to transfer exciting data through several processes. For DMA, you basically need hardware called DMAC. It's Direct Memory Access Controller, which will help in the entire process of data transfer between the memory and IO device directly. And this is an example how DMA is processed. You can pause this video if you want to see the process. Okay, I want to talk about advantages and disadvantages of the DMA. Okay, first we talk about the advantage. The advantage of using DNA is can emulate some process function, and second, can take over the process function related to the data transfer. Okay, for the disadvantage of DNA, first is limited data transfer rate, and second is still required CPU involvement, so the CPU get busier. Okay, that's all my explanation about DMA. Thank you.